Recently, I conducted a poll on LinkedIn asking a vibrant tech community that which programming language or languages they thought was, or were most dominantly used in F-35 aircraft. I included the options of Ada, Java, C and C++ combined, and Python. Seemingly, it is a straightforward question being asked from a tech community that has many software engineers in it. Do you know? What was the result of this poll? The majority picked the C and C++ combination. And that is quite right as far as the question goes. Because, according to various sources that are available online, the millions of lines of code that power the F-35 fighter jet, one of the most advanced fighters at this time, has about 53% of its code written in C language. 35% written in C++, 7% in assembly language, and just 5% written in Ada. Keeping in mind that Ada programming language was actually designed primarily for this kind of applications, and its development was actually sponsored by the United States government. But in the longer run, C and C++ seem to win in this domain. But there is another aspect of looking at this poll data. And that is, more than half, precisely speaking, 54% of the community, is wrong here. In fact, I was expecting that C and C++ will have a tie against Ada. You can well understand how I felt by looking at Python at the second number. The choice of 29% of voters. Nothing against Python as a programming language, but it is not used for this kind of purposes. At least at this time. To me, it simply shows that the majority is not right in this case. Perhaps, the huge number out there in the software industry doesn't know the embedded world well enough. Additionally, in older times when you had to physically replace chips to update a system, back then there was a stark difference between firmware and software. But the newer devices allow you to make updates over the air. Thus, firmware, whether you agree or not, is basically a software these days. And I've seen many engineers who approach it the same way. You can find so many people telling how to design your software and what the best practices are in this field. So the question arises that, how much does the advice on software design is valid for embedded software or firmware development? After all, they seem to be the same thing from many perspectives. Especially, they both keep growing over time, keep changing to meet requirements, keep updating to align with needs, and keep adding new features over the life cycle. Hence, both need to be designed for robustness. In fact, many embedded applications need to be much more robust than a simple desktop, mobile, or web application. Why? Because there may be lives involved, or simply because the device might be functioning on another planet. So hi. Aimo-sama. With over 25 years of development experience in various languages and platforms, and over a decade of working experience in the aviation industry, I welcome you to my course on design patterns for embedded applications. We will discuss some relevant design patterns and best practices for developing robust, extensible and manageable embedded systems. You can reach out to me on X or Twitter with any kind of questions on this course or any related topic. I'll try to guide you and would love to learn from your experiences. Additionally, all the examples, exercises and their solutions are hosted on GitHub. You can download from there to follow along. With this, I'm excited to begin. Before we begin, let's first define what kind of embedded applications are we talking about in the context of this course? We are talking about all the hosted and freestanding embedded applications. Whether you are using a system on a chip to run Linux or Windows to host your embedded application, or you are using a microcontroller to run your application directly or using a real-time operating system. But we will be mostly using Arduino and some examples from other environments as well to clarify concepts. You might ask, why Arduino? It is because Arduino is most widely used in the embedded world by the beginners. And, more importantly, its default development environment allows writing haphazard code without complaints. That, in my opinion, encourages people to overlook many things that we would talk about in this course. This course is intended for the beginner to mid-level embedded developers who already know some embedded development with C and/or C++. And those who want to further enhance their embedded development skills to design better, more robust, stable, and large-scale embedded applications. I hope that you'll find this course helpful in improving your development skills. I'd love to hear from you, learn from you, and your feedbacks on how to further improve this course to better suit the audience. With this, let's begin.